This is the Physical Activity Researcher Podcast, a podcast for researchers of sedentary behavior, physical activity, and sports. Join for a relaxed dialogue about research design, practicalities, and, well, anything related to research. Learn from your fellow researchers useful and relevant information that does not fit into formal content and limited space of scientific publications. And here is your host, researcher and entrepreneur, Olli Tikkanen.
Welcome everyone. I am very excited about the guest of today's episode. His research relates to rehabilitation, exercise science, and cryotherapy. He has published numerous peer-reviewed papers and popular articles about cryotherapy. He has also authored a book about the influence of cryotherapy to enhance performance and recovery. Currently, he is the postdoctoral researcher at the University of Portsmouth. Ladies and gentlemen, I am honored to introduce our guest, Erich Hohenauer. Welcome, Erich.
Thank you, Olli, very much for this kind introduction.
Yeah, did I pronounce your name even close to correct?
Yes, that was very close.
All right, thank you. You're polite. All right, so Google reveals me that it's 12 degrees Celsius in Portsmouth. Does that count by any degree as cryotherapy?
No, that's probably a little bit too high to be called a cryotherapy.
All right. So what kind of temperatures you basically need for cryotherapy?
Normally, it depends on which medium we are talking about. There are several methods to apply cryotherapy. The most popular forms are using air or vaporized nitrogen, but also water. And all of the different mediums have different temperatures which are traditionally used.
Yeah. So if we're talking first about air, what is the temperature threshold?
Right now, we are having a very new situation that that cold air is used in sport settings. Traditionally, whole body cryotherapy, for example, or partial body cryotherapy, or in general, cold air was used to treat rheumatic patients, and that was invented in Japan. And it's becoming more and more popular now in a sport setting to enhance recovery and performance. And normally the temperature in these cryotherapy chambers or cabins are below minus 60 degrees, and they go up, for example, in a cabin, up to minus 195 degrees Celsius.
All right, it sounds quite freezing.
Yes, it is very cold, but it is a very dry cold.
And is air superior to water, or how does it go?
No, it is when it has to do with the thermal conductivity of each material. And when you look, for example, the highest heat extraction can be achieved with a melting ice, which is followed by water, and then we have air. So we can extract heat 24 times more with water compared to air. So this is also the reason why we don't have to go that deep with the temperatures for water, because that's the thermal conductivity of that medium is much higher than to air.
Yeah, makes sense. And in cryotherapy, is the idea to kind of have the skin as cold as possible, or get the core temperature low quickly?
Yeah, that's a good question. The access organ of a cryotherapy is obviously the skin, but when we are looking, for example, for precooling, so when we cool in front of an exercise, the aim is to cool either the shell temperature or the core temperature. So the idea behind this is to enlarge the temperature gradient between the core and the shell temperature. While when we go for post-exercise cooling, we are mostly interested not to decrease the core temperature, but to decrease the tissue temperature, for example, of the muscle. So there are different concepts behind it.
Yeah. So why do you want to have the contrast in the pre-cooling? Why do you want to have the difference between core and cell temperature?
Yeah, that is because what we know is that the core temperature under resting conditions is normally 37 degrees centigrade, and the shell temperature is around 32, 33 degrees. So that's the main mechanism why the heat can be transported from the core to the shell, especially when the environmental temperature is very low. We have mainly four mechanisms to extract the heat from the inner body to the outside, and these are evaporation, radiation, convection, and conduction. And all of these four mechanisms work quite well. However, when the environmental temperatures increase, or when we exercise, the core and the shell temperature will increase. And we will have the problem is that heat flow goes only from high to low. So once the environmental temperature is higher than, for example, the core or the shell temperature, it is very tricky for the body to get rid of that heat. And so what we have to do is we have to increase our skin blood flow to maintain the heat transfer as well as the heart rate to guarantee an adequate cardiac output. However, in that ongoing situation, the stroke volume of the heart has to decrease because of the increase in the core temperature. And that is because of the reduction of the cardiac filling pressure and of the shorter diastolic filling time of the heart. It's also called the cardiovascular drift. And what we are aim with pre-cooling is to lower even the shell temperature or the core temperature so that we can have this heat transfer to the environment going on. And this is what you will also see when you, for example, do a cycle ergometer test. And your body heats up. Immediately when you open the window, you will have this chill effect from the air, and then your heart rate will decrease because you have a redistribution of blood back to the muscles. And normally when you heat up, this blood has to be delivered to the skin to cool your body. While when you have a cool skin temperature or a core temperature, the blood is more distributed to the working muscles. So these heat gaining environments are always performance limitations.
That's very interesting. Let's have a short break and hear a few words from our sponsor.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Furthermore, Fibion has been shown to be valid categorizing physical activity into light, moderate and vigorous intensity. In addition to scientific accuracy, Fibion provides automatically produced and easy-to-understand reports for research participants. Get scientific validation and learn more about Fibion at fibion.com/research.
Yeah. So when do you use the pre-cooling? What kind of situations?
We did a meta-analysis on this topic and looking which pre-cooling modality is the most effective one and under which environmental conditions. What I have to say is the most efficient way when you're working to get rid of the heat is the evaporation of sweat. That makes around 80% of your heat loss. However, evaporation is strongly dependent on the relative humidity. So once the relative humidity will increase, your evaporation rate will decrease. So there's an inverse relationship between these two parameters. And the same is true for the temperature, for the reasons I said before. So the best would be when you pre-cool on temperatures which are above 29 degrees centigrade, and when your relative humidity is above 30%. So then you will see a positive effect of pre-cooling. So these are the thresholds. The higher the environmental temperature and the higher the relative humidity is, the stronger effects you will see with pre-cooling methods.
And how much these pre-cooling things are being used in the sport and for example athletics?
Yeah, they are getting more and more popular. However, it's always the case that especially in elite sports, that the use of an intervention is not related directly to the amount of published articles. So it's but it is very well used in the athletic field. And for example, for pre-cooling, we know basically external pre-cooling methods, internal pre-cooling methods, and mixed methods. And I think it will become very popular, especially when we look into the future and the upcoming Olympic Games in Tokyo, which are supposed to be the hottest Olympic Games ever on the planet.
Yeah. So in practical terms, how do you do it? How close to the competition you need to do it, and what do you need? It's probably not easy always to do it in the athletic venue.
That is true. It is often a logistical problem, and therefore internal cooling methods are very popular. So internal pre-cooling methods are, for example, to drink some cold water, and there we have to mention that the amount of water you should intake then is between 1 to 1.5 liter, and the water temperature has to be below 4 degrees centigrade to be effective. Or what is also popular is that you ingest crushed ice, and the normal amount for crushed ice intake is 6 to 8 gram per kilogram body weight. So that's normally a very easy way to do a pre-cooling method. However, we have also other forms, for example, cooling vests, which are used, and they are normally applied between 10 to 65 minutes in front of the exercise. And what is very effective is one of the most effective methods for pre-cooling are still cold water immersion, because I told it already before, with water you can extract very much heat from the body. And so normally when you do cold water immersion as a pre-cooling method, you apply it for around 10 degrees and use 8 to 10 minutes, or you can go for a little bit warmer temperatures, 23 to 24 degrees centigrade, and apply it 30 to 60 minutes in front of an exercise. However, that is not always capable, because you need a tub, you need a constant water temperatures, and you need a lot of water to up to the sternal level.
So how does it work with the warm-up? Anyway, your joints needs to be warmed up for many sports. Is there any conflict between cooling the body but then kind of keeping it warmed up, especially the joints?
Yeah, it is. That is true. So what we see for what a problem could be when you cool down joints, and this has already been shown from a colleague from us, from Joseph Costello. When you cool down your joints, you may get a problem for the joint positioning sense. So this means you might have a higher risk of getting injured when your joint temperature is low. And that risk will be will be present until the tissue has came back to the baseline to the baseline temperature. However, what we pre-cooling is especially effective for enhancing endurance performance. So all kind of open-end tests, for example, endurance running or endurance cycling. We don't see that much positive results of pre-cooling when we look at maximum performances. For example, sprinting times are not affected from a pre-cooling. Also, peak power output is not affected from a pre-cooling, and that might also have to do with the muscle temperatures. When you have a slightly cooler muscle temperature around 27 to 29 degrees, your endurance performance will increase, while for maximal effort, you need slightly higher muscle temperatures, because the lower muscle temperatures will impair the muscle contractility. And also the muscle blood flow will be redirected to other portions, and so the working muscles will not have enough blood. So the risk is countable, I would say. It is when you have low impact, the risk is probably lower compared when you have, for example, a sprinting exercise. When you would apply a pre-cooling method there, I think your risk will increase compared to that endurance exercise.
Yeah, makes sense. So how do you do the sequence between cooling and kind of warming up or doing the movements, kind of getting ready for the competition?
So the idea of pre-cooling is there are two ways. What you can do is to rest in front of the competition, and then applying your pre-cooling method, trying to get as cold as possible. But what you also can do is pre-cool your shell while doing your warming up. So what you will create there is you're warming up your muscles, but you're not wasting energy to cool down your skin. So this is a quite common method. For example, on a cycle or in front of a cycle tournament, the people are sitting on a cycle ergometer and they are warming up and wearing a cooling vest, for example. And and that is a practical thing. So when you're sitting in the cold water immersion, obviously you have to rest. And when you wear a cooling vest or when you are ingesting a drink, you can work at the same time.
Yeah. And is there any evidence that some of these would be better vest or internal or external cooling?
Yeah, that is conflicting in the literature. What we see is very strong effects of cold water immersions, but also the cooling vests and the combination of cooling vests and, for example, thigh cuffs. So the more of your body surface you are cool, the better. There is also evidence available that internal cooling has a beneficial effect on performance, but in the literature it is a discussing point which of all of these techniques is the best. It is obviously harder to decrease the core temperature via internal cooling or via external cooling than to cool down the shell temperature, which is very easy when you cover a large surface area. So I would
so I was about to ask, like, just if it's 1.5 liter of water, which is 4 Celsius, and then you compare it to 23 degrees water that you are for half an hour, is it the same amount of kind of temperature change in the body?
I wouldn't say that, no, because with your internal cooling, you will or you can decrease, for example, your gastrointestinal temperature for a certain amount, and what is also discussed in the literature is that you maybe promote sensory advantages when you ingest cold water, which you won't have, for example, with a cold water immersion. Most of the people don't feel that cold water immersion very comfortable. However, with cold water immersion, you will definitely affect the skin temperature and probably the core temperature. So these are two different concepts of cooling.
And how about the hydration during the race? So basically, you can drink sports drink, either
Absolutely.
cold or body temperature. What should it be?
I think that is a very good point, because with internal cooling, you have this possibility to deliver nutrients to the athlete, for example, the fluid, which is the main factor, but then also carbohydrates and electrolytes. So I think that is a main advantage when you do internal cooling, because you have this positive side effect to deliver these additional nutritions to the athlete. While this pre-cooling via cold water immersion, that is only possible for a certain time. But during the race, you cannot help the athlete with that method. So it might be good to pre-cool the athlete with a cold water immersion in front of the race, which is a very effective method to get down the shell temperature. And during the race, if it's possible, provide him with internal cooling beverages so that he has these additional nutritions during the race.
So if you drink cold water or cold sports drink during the race, it will be absorbed slower, but then on the other hand, it will help you cool in the cooling process. And you think it's beneficial more the cooling process than the slower absorption?
Yeah, I think so. I think so that this might be the case, because the internal cooling will decrease the amount of building up the heat inside the body.
Yeah. No, that's interesting. I think I will have a competitive advantage in my next race.
But remember, it should be hot and humid.
Yeah. No, I'm not sure. I might be taking part in a running competition in Wales, which is like running. You have 3 persons in a team, and you run 24 hours up the mountain, the biggest mountain in Wales, the Snowdon.
Oh wow! Okay.
So, but I think probably the weather is not that warm that I will get the edge from this one. Yeah. So we could move to the post-cooling, or do you have something you would like to say about the pre-cooling?
No, that is fine for me.
Yeah. Yeah. So tell us about post-cooling. What's important in that?
Yeah, for post-exercise cooling, that is normally it was also traditionally used in the therapeutical setting just to relieve pain. And that was, for example, after muscle injuries. And we all know we have these 3 main phases after a muscle injury: the destruction phase, the repair phase, and the remodeling phase, where scar tissue is built up and the recovery of the muscle function. And already there, cryotherapy was discussed controversially if cooling after an injury has a beneficial effect, because the tissue perfusion is reduced, and also the nociception. The nociception is reduced after the cooling, and people were discussing if it has a negative effect on tissue regeneration. So right now, what we see is that this post-cooling from injuries moved also into the athletic field. And nowadays it's used as a recovery modality, so that you are that you can perform higher and better at an earlier point of time. And traditionally, it is used after the occurrence of exercise-induced after delayed onset of muscle soreness, which will occur after the unaccustomed high-intensity exercises. And everybody knows it. That's the disruption of these of the microscopic parts of the muscle, the sarcomere, sarcoplasmatic reticulum, and the excitation contraction coupling system. And all of these will lead to these delayed onset of muscle soreness symptoms. And delayed onset of muscle soreness is well known to limit recovery, because it will lead to muscle swelling, sore muscles, reduced range of motion, and loss of muscle strength and power. So also there we have some very popular modalities which are used. However, compared to pre-cooling, these modalities are naturally just externally applied. So we have local applications like cold cuffs or cold packs. We have, for example, again, these cold water immersions, and nowadays very popular partial body cryotherapy or even whole body cryotherapy. The aim of all of these cooling applications are the same. What they want is to decrease the metabolism, to reduce the inflammation via a vasoconstriction. And
go on.
Yeah, and all of these different modalities have different effectiveness. So we have studied a variety of these applications where we applied different cooling modalities after muscle damaging protocols in males, but also in females. And we had a look which of one is the most effective to enhance performance recovery.
So basically it's done to decrease the inflammation, but isn't it also that inflammation is kind of necessary part for muscle growth, or it kind of improves it?
Absolutely. Yeah, that's a very good point. I think we have to use a post-exercise cooling in a very clever way. I would agree, or I would suggest to use, for example, post-exercise cooling in the tournament settings, when you're not interested in muscle growth, but when you're interested that your participant or your athlete can perform as high as possible, because then you can decrease these the metabolism and also the inflammation. However, I wouldn't suggest to use post-exercise cooling after a strength training, because as you said, it might attenuate muscle adaptation following strength training, and this is something you don't want. So when you go training, it is good to have this delayed onset of muscle soreness, and leave the delayed onset of muscle soreness symptoms go on, because they will lead to these adaptations of the muscle. And when you cool it artificially down, you will attenuate these adaptation processes.
Yeah. So basically it's about whether your intention is to have muscle growth, that whether you should be cooling. I'm thinking just like, for example, some skill sports where the main point is skill, but during training you will get muscle damage. Would you say that it's good to cool after those training, because probably the muscle strength is not the main point in that sport?
I would suggest, even when your training is a skill training, that you should not influence the physiological processes which are going on, because it's not only because of the adaptations of the muscle, but what you also will do is, for example, decrease the nerve conduction velocity. And so all of the neuromuscular adaptations, which will go on after this training, might be negatively influenced after the post-exercise cooling. So when your intention is to train, I would rather suggest that you leave the muscle as it is and don't interact with that recovery process. While when you're in a tournament and you're not interested in building up skills or muscle strength, then you can apply a post-exercise cryotherapy to be fit on the next day as much as possible.
All right. So basically, only in the competition, when you need to be in shape, you would recommend using it. I think quite many sprinters, I think they use it after the training sessions. Do you think it's not the best thing to do?
I wouldn't do that, to be honest. I would, as I said, I would leave the muscle as it is, because all these physiological processes which are going on after the training, they make good sense. And I wouldn't interact with these processes.
And if we go back to the injury, when would you apply ice? For example, if there's a twisted ankle and it doesn't swell like really fast, you hear the snap, it's a bit painful, but it's not swelling like that much. Would you put ice or not?
I would put on the ice if it is necessary. So when you are in a lot of pain, then I would apply the ice. Otherwise, what you could do to reduce the edema, for example, is that you take a compression bandage around the ankle. So this will also reduce the swelling, but will not interact with the physiological processes which are going on after this tissue damage.
Yeah, makes all the sense. Yeah. So now we have covered the injury and the post-cooling. So how would you do the post-cooling in a tournament setting?
Yeah. What I can suggest from our research is that you should also cover a very large skin surface area. There is only limited evidence available that shows that a local post-exercise cooling has a positive effect on recovery. So, for example, cold cuffs or cold ice bags, because you won't cover the entire muscle with these devices. What we see is that, again, a very strong and probably one of the strongest effects we will see for post-exercise cooling is again with cold water immersions. And this is normally more visible after exercise than pre-cooling, because you have much more time after the race. And the optimal temperatures which you should use for a post-exercise cooling should be between the water temperature should be between 5 to 15 degrees Celsius, and the duration should be around 10 to 24 minutes. And we have seen that cold water immersions can efficiently recover subjective but also objective recovery outcomes. The very new things which we see for partial body cryotherapy and whole body cryotherapy, I think there is only limited evidence available today, and we need much more studies to confirm this, whether to prove if this method is efficient or not. I think what very important is for post-exercise cooling is to consider if you apply it for male or for females, for example. So that will make a big difference. Because what we have also seen in our studies is that there is no one fits all method for post-exercise cooling. We know that the women have a different amount of body fat, but also a different distribution of body fat, especially around the gluteofemoral part. And that will make it a little bit more trickier to extract that heat from the female body, because we know that the thermal conductivity of fat is 2 times lower compared to that of muscle. So when we use the recommended temperatures and duration, we might have effect in male participants, but the effect in female participants is questionable. And there is also not much research today available which has investigated post-exercise cooling in a female population. So the amount of fat is a big thing which we should consider, male and female, and for example also the training status of the males. So when we have a well-trained male with a very low body fat percentage, this guy will profit much more from post-exercise cooling than a recreational active, which compared to the well-trained athlete, a higher amount of body fat. I think that is important to mention.
Yeah, can you just overcome it by kind of having a longer cooling period if there's more adipose tissue?
Yes. Then you definitely have to. I wouldn't go much lower with the water temperatures, because 5 to 15 degrees, that is already very cold. But I would enlarge the application time.
Yeah, that makes all the sense. Yeah,
we can also make. You could also provide, for example, a skin fold measurements. We know that, for example, when you have a skin fold below 20 millimeters, and you have a skin fold, for example, for 50 to 60 millimeters, that your cooling time will double when to reach the same amount of tissue temperature.
This podcast is sponsored by Fibion, a research device that has been shown to be valid in tracking sitting, standing, physical activity and energy expenditure. Get scientific validation and learn more about Fibion at fibion.com/research.
And from a practical perspective, usually you have an access to shower. Can you do it well with the shower? Is the water cold enough, and you can apply it only part of the body at its time point? Do you think it's feasible to do it with shower?
I think when you don't have the access to a water tub, it is worth trying it with a shower. However, what you will be missing in a shower will be the hydrostatic pressure, which you will have in the water tub, and especially this hydrostatic pressure seems to have at least an effect to enhance the recovery process, because it will lead to a redistribution of blood into the abdominal region, and this you might not have when you use a shower. So whenever it's possible, I would take a tub and to fill it up with cold water, add some ice, because that is very easy to control. And when it's not possible, then you might go into a cold shower. But I think that's not the same. It's comparable, but it's not the same.
Yeah, makes sense. And if I try to summarize, so basically you use the pre-cooling in the competition setting, you get the advantage from that, and post-cooling you would only use in the tournament kind of setting. So am I correct?
Absolutely, yeah.
All right, and this, I think quite many athletes use it then a little bit wrong. They use it after exercise, and also these air cryotherapies are marketed with the big advantages.
Absolutely, and you see the top athletes using different post-exercise cryotherapy methods, but nobody really questions if it makes sense or not after a training. And we know already from the literature that applying cold after strength training will reduce the adaptation to as the strength training exercise.
Yeah, yeah. I think many athletes probably like to go to the cold water because then they feel that they are sacrificing. They even are ready to go to ice cold water after every session. So probably it's good for them.
You definitely feel refreshed after it.
Yeah, yeah, and you have given everything you have.
Yeah, true.
Yeah. So how about I'm from Finland, so we have a lot of saunas. How about the hot temperature after a training or a race, or before or after?
We have a PhD student in our laboratory who is just going to investigate this. So basically, she will have a look how hot temperatures will affect the recovery after muscle damage or after a strenuous exercise.
Yeah.
So I cannot really say something about this right now, and I don't know the literature very well.
Yeah. So do you have any guesses? Anyway, you know quite a bit about the inflammation process. Would it make sense that it actually increases the inflammation? And do you guess that it would be good or bad?
If I had to guess, I would say that normally what I would expect is that the hot temperatures after a training might increase the inflammatory response. It might be interesting to have a look if this increase in the inflammation is beneficial, so that if you would get better even more when you really increase that inflammation, or if it's harmful when you have this extra inflammation. That might be an interesting point to look at. And in front of preheating, for example, I think that can have a positive effect on, for example, maximal exercises like sprints, peak power output, because we know that slightly warmer muscle temperatures will lead to higher performance outputs. But I wouldn't use, for example, a preheating protocol before of a cycling or endurance running competition, because it's obvious that this might limit your performance output in the future then.
Yeah. And what's your take on, I don't know how it's called, is it the contrast therapy that you alternate between cold and hot? What do you think about that?
Yeah, this has also been shown to be an effective method to enhance recovery. However, if cooling or contrast water therapy is better, this is something we have to look in the future to compare it. So there is literature available who shows that post-exercise cooling has a beneficial effect. Also, contrast temperature or contrast water therapy has shown to be effective. But now we have to look which of these interventions is the best. If it's post-exercise cooling, contrast, or even post-exercise heating.
Yeah. No, that will be interesting findings from the studies. And how about cold exposure for health reasons? You know, in Finland we have a lot of lakes, and 6 months of the year they are frozen, but we make holes to them and we jump in. What do you think about that?
Yeah, it has shown that these cooling therapies have a beneficial effect, not only on well-being, but also on the immune system. So when you do that regularly, but I have to say under a controlled condition, because jumping in that extreme cold water is also very dangerous. This might have a positive effect on your immune function.
And what do you say? What would be the longest time you should do that? Because at least like from a kind of a personal experience is that if you go outside and it's cold, you easily get upper respiratory tract inflammation or kind of a flu-like symptoms. How long should it be that it's healthy and when it turns unhealthy?
I think there is no real number or time which someone can propose. I think that's very individual, and that's an experience everybody has to make by him or herself. I think it's a trying out. So I think when you do this kind of cold therapies, you should start slowly. So starting, for example, in the shower back home, getting always a little bit of colder and colder water, starting from a couple of minutes, and then extend the time. Then you go out, and then you will see when you feel comfortable and when your body will react strange. And I think when your body reacts different than you expected, and when you don't feel well, then you know that is your personal limit at this time. And with this personal limit, you can play around. So then you can try to push this border more and more and more.
And is the idea to get the core temperature down, or is it about skin cooling, or what do you think is the mechanism?
Mainly, it is the mechanism to change the metabolism. So when you have metabolic changes, this will lead to acclimation effects to the cold. And it's not only the shell temperature, but you really have to influence the metabolism of your body to have an effect of the cooling. You can metabolically adapt. You can also get more insulation when you have when you are exposed to very cold regularly, and you can also get hypothermic. So you can naturally decrease your core temperature when you are regularly exposed to cold. And these are just 3 main mechanisms of cold adaptation. But you definitely have to affect your metabolism and not only the shell.
So to affect the metabolism, you need to change the core temperature. Am I correct?
Exactly.
All right.
Exactly.
Yeah. And if you're exposed to cold, I think the kind of natural reaction for the body would be that this person needs more adipose tissue. Is there a link between appetite and adipose tissue and then cold exposure?
That's a very good question. We don't know exactly which one of these adaptation will occur. We see there is a trend, and we see that people who have already a little bit a higher amount of body fat will react to regular cold with insulative adaptation. So this means they will gain more body fat, while we see, for example, for athletes, that they will mainly metabolically adapt. But the mechanism, which one is for who, is not clear right now.
All right. And why do you think there's a difference? Could it be related to the amount of fat cells, that when you have higher adipose tissue, you actually have fat cells to be filled, but if you have been lean all your life, you don't have the kind of excess fat cells?
I think that might be a reason which can count for this kind of adaptations. But I also think that it has with the entire metabolism to do. So when you are an athlete with very low amount of body fat, your metabolism is already very high, and changes on your metabolism are quite common. While when you have a little bit a higher amount of body fat, your metabolism is a little bit lower compared to a trained athlete. And I think also, as you said before, with the fat cells, this might lead that you will gain much more into this insulation, gain more fat cells, because the metabolism is lower.
Yeah. So would you recommend cold exposure for overweight people, or what is your take?
I wouldn't recommend that to overweight. In the first attempt, I would suggest that they perform physical activity.
Yeah.
To reduce their body fat, and I wouldn't suggest to go into the cold right now. I think there are other problems for obese people which they should cope first before thinking about cold therapy.
All right. Yeah, that's interesting. This is very interesting when you live in Finland and the temperature starts to be freezing, and even
absolutely.
Yeah, even a bike ride to office is kind of a cryotherapy with the wind factor and everything. So I'm very interested. Let me see. So how about the brown adipose tissue? There's some research on it. Have you read these kind of papers?
I didn't had a close read into that section. No, sorry.
Yeah, that's no problem. And let me see. So we have gone quite many of the things. Yeah, and I also noticed from your publications that some of your colleagues have been doing about mountain bike injuries. Have you been? How much you have been involved in these studies?
Yeah, we did some a survey for mountain biking.
Yeah,
and we looked at different risk factors. So if people which are untrained, if they have a higher risk of mountain bike related injuries compared to very well trained athletes. And we performed this survey of a 1 week mountain bike race in Switzerland.
Yeah. All right. And we talked in the beginning about your book. So where can people find the book if they are interested?
I'm happy to give them a copy in the PDF version. It's can be found on ResearchGate, or if they contact me directly.
Yeah, and what is the best way to contact you?
The best way is via mail.
All right, that's good. So if you're interested about the influence of cryotherapy to enhance performance and recovery, write an email to Erich and he can share it. It's been very, very interesting discussions. I have learned quite a bit about cryotherapy, and thank you for taking the time for this podcast.
Thank you, Ollie, very much. It was nice discussing with you.
This podcast is sponsored by Fibion. Get scientific validation and learn more about Fibion at fibion.com/research. The Physical Activity Researcher podcast has created an activity tracker purchase guide for researchers. Get your free copy from the link in the podcast description.
Thank you for listening to the Physical Activity Researcher podcast.